A right triangle has one of its three angles measuring 90 degrees. Due to the uniqueness of this type of triangles, many geometric facts are based on triangle similarity. Before going into the first fact, remember that if any two or more triangles are similar, then all three pairs of corresponding side lengths are proportional. One fact states that if an altitude is constructed from the right angle to the hypotenuse of the triangle, the three triangles become similar. Let's paraphrase this fact. Drawing an altitude ZS as shown in the figure forms another two smaller triangles. Each of the newly formed triangles is similar to the original triangle by the angle or AA similarity. From that, it's legitimate to conclude that all three triangles are similar and therefore any corresponding side pairs are proportional. In other words, triangles XYZ, XZS, and ZYS are all similar. Now let's look at the question. Use the figure below to find length of side XY if side YZ equals 7 inches and side SY equals 3 inches. The first step is to transfer all given information to the figure to have a clear picture of how the information is relevant to the triangles. Side YZ is 7 inches and side SY is 3 inches. The hypotenuse XY is the unknown. To find length of side XY, we must first find the length of the missing part of it, XS. However, it's clear that segment XS is also a side in triangle XZS. To be able to use fact 1, all three triangles must be oriented the same way to be able to easily identify corresponding sides. For visual illustration, the top triangle is colored in green and the bottom in red. Now peel the green triangle of the original triangle XYZ, then keep changing its position till it matches the same spatial orientation as triangle XYZ. It's clear that the vertex of the right angle was called S in the original triangle, so label it as S' on the green triangle. The shorter side connecting the right angle and the acute angle Z makes us label this vertex as Z' on the green triangle. Finally, label the last vertex as X'. Now it's clear which sides on the green triangle correspond to which sides on the original triangle. Do the same process for the red triangle. Take it out of the bigger triangle and change its position to match the original triangle. Again, S' is where the right angle is at, Y" is the end point of the shorter side, and Z" is the remaining vertex. Let's get back again to the question. YZ is 7 and SY is 3 inches. Look at the red triangle. Two of its sides, Z', Y', and Y', S' are of the same lengths as side YZ and segment SY on the original triangle, respectively. Therefore, write those lengths on the red triangle. Now let's sit back and look at what we know so far about the three triangles. Remember, we're still trying to calculate the length of segment SX or side X', S' on the green triangle. However, to be able to use a proportion between the green and the red triangles to find length of X', S', another side on the green triangle must be calculated first. Look at the red triangle. Two sides are known. Since this is a right triangle, then Pythagorean theorem can be used to find the third side, Z', S', which is the same length as Z', S' on the green triangle. Write out the equation. The sum of the squares of the two legs of a right triangle must equal the square of its hypotenuse. This means that y double prime z double prime squared equals s double prime z double prime squared plus s double prime y double prime squared. Now substitute the known lengths in the equation. 7 squared equals the unknown length squared plus 3 squared. Next, it's 49 equals s double prime z double prime squared plus 9. Apply the basic algebraic step of isolating the unknown on one side. So 49 minus 9 equals the unknown, or 40 equals the squared length of the side. Take the square root of both sides of the equation. The length of s double prime z double prime is 6.32 inches. This side is congruent or equal to side z prime s prime on the green triangle. Only now a proportion can be used based on the fact that the two smaller triangles are similar. Set up the proportion such that each fraction comes from the same triangle and corresponding pairs appear at the same position on each fraction. So, since x prime s prime and z double prime s double prime are corresponding sides, they both appear on the numerators. Z prime s prime and y double prime s double prime appear on the denominators. Plug the three known values in the proportion. There is only one unknown. Solve by cross multiplication and division by the third value. So, length of x prime s prime equals 6.32 times 6.32 divided by 3. Multiply the numerator, it's 39.94, then divide by 3. X prime s prime is 13.31 inches, which is the same length as segment XS on the original triangle. Looking back at the question, it's asking for the length of the hypotenuse XY. Then add length of XS and SY. It's 13.31 plus 3. XY is 16.31 inches.